Hey everybody, welcome back. Hey, guess what? We had some time this week and I managed to finish the build of the ESX side of the topology. Now while it's sitting right there and it's all complete, it's kind of tough to see what's going on. So I'll be going through some screen caps and some ESX topology diagrams so you guys can see what happened. So without further ado, here's the ESX side of the same SDN topology. All right, boys and girls, we are back. We are completing our ESX build in what we might call phase 3 of this first portion of our SDN Odyssey. Now to get us started, remember that this was an SDN build, but it's supported by a small network that I've got set up here in my office. So we're connecting to the RIT network, but we're connecting through a router. And there's a hardware switch, a standard Ethernet switch, and then there's the ESX box itself with all the VMs and all that crunchy SDN goodness. Now if we populate this with a little bit of addressing, we can see that really we've got two networks here. We have the 10net and the 2net. The 10net is straight up management, so my ESX Management Interface and my vSphere management node. I've got the router running NAT, the outside interface is a DHCP based address, and then I have the 2net, and I'm using the 2net for my VM hosts and my router interface to get them out. Now I did sneak in a third network. You can see it all the way on the right there, and that is a network, the 3net, is there just to allow my OVS switch to communicate with the controller. I wanted sort of an isolated traffic stream for that. There are some big ideas involved here. First is that you have a separate network and VLAN for your management. This is very standard practice. You don't want your management traffic to be out there on the production network. And if you think about that another way, you don't want users of the network to be able to touch or reach your management interfaces. That would be bad. I also installed that separate network for communication between the OVS switch and the controller, although I didn't have to. In fact, sometimes you can even build a controller on the same box as the Open vSwitch. But I wanted to be able to capture traffic should I decide that OpenFlow becomes really, really interesting that week. Now, one thing that had me stumped for just a moment, in that I wasn't sure how to design it in the best way, was that I am deploying an Open vSwitch on a box that comes with a vSwitch or a virtual switch. So let me see if I got this straight. I'm going to put OVS on a box that already has vSwitches. How do I manage this? Well, in the end, what I decided to do was install another vSwitch and then use OVS or Open vSwitch to bridge between the two of them. And that was the way that I would isolate some of my VMs and make sure that they had to flow through my configuration. And then lastly, I wanted to figure out some traffic flows to verify that it was in fact working because of my configuration and not because of any screw-up that I might have had. Here is my ESX Management Interface. You can see on the left I've got 4 VMs running there, 2 hosts, the controller, and Open vSwitch itself. And then the more complicated thing in the middle is what we really need to talk about here. Now, I have a better graphic for this in a second, but I'll just show you that by default, ESX gives you that vSwitch 0 at the top there. And what you do normally is you divide up, or you organize your VMs based on IP addresses and VLANs, and then you create a VMnet to house them. You can also see my management network is right there. You can also see that I'm trunking into my ESX box. That's the 4095 VLAN ID. The one on the bottom, vSwitch 1, that's what I added to isolate the nodes on the bottom so that they had to flow through Open vSwitch. Now the thing that makes these sometimes difficult is that it's hard to see how all the flow paths work. So let me see if we can't clean this up a little bit. This is how the traffic actually flows, or how they're actually wired. If you take a look, you can see that the OVS VM, you see it there, Ubuntu 14.1 Open vSwitch, actually has 3 different interfaces, 3 different virtual NICs, and they are connected
to 3 different places. We've got the VM network 02, VM network 03, and then VM network 12. And the hosts that are connected there get their traffic forwarded through OVS via the pathways that I've sort of indicated. The controller is also connected to VM network 03, and so that's how the controller and the OVS VM actually communicate. Just a quick word on the VMs in the software. Remember that I'm using Ubuntu for all of the VMs, and the ISOs and the VMs are all stored locally. Well, the one ISO that I'm using. For OVS, all that I did after I got the install, or after I got the VM on its feet, was that I did an apt-get install of the Open vSwitch components, and then on the controller I installed Git, and then I brought down the POX repo. This topology is the exact same one that we did in the last video, but we did it on GENI. So the same commands had to be issued on OVS, the add port commands, the set controller, and here's the output on my OVS VM using the OVS VS control show command. So you can see that it's the exact same thing that we had last time, but I wanted to show it to you so that you could verify that nothing was different. Once the controller came up, here were the flows that were being installed on the OVS VM. Remember that these go inside the flow table and describe how the control plane on OVS is going to forward traffic. On the controller, again, the exact same command. The forwarding layer 2 learning command was issued, so the Python scripts are running, and once the controller starts communicating with the OVS VM, this is what you see there. You see that the OpenFlow messages are going to be installed, and that this is the communication that's going between the 2 boxes. So I want to test this now. How do I make sure that it's doing what it's supposed to? Well, host 1 and host 2 are both DHCP clients. Host 1 is on the physical NIC side close to the actual router that's serving as my DHCP server. So it'll get a DHCP-based address. But host 2 will not, because it's connected through OVS. So everything downstream of OVS will not work unless the controller is running. And nobody should be able to talk to those downstream hosts without Open vSwitch installing the flows. So for my test was not only that the DHCP addresses worked all around the network, but also that host 1 should be able to ping host 2, and that host 2 should be able to get out to the outside world. And here's a look at those 2 pathways. The green line on the left indicates host 1 communicating with host 2. And the purple line on the right indicates that host 2 is trying to get all the way out to the outside world. By way of a little bit of proof, both hosts got DHCP-based addresses, although host 2 was the only one that really needed OVS to be configured properly. And then just for fun, I threw in the ping to 8.8.8.8, and that shows me that I can get all the way out to the real world, and huzzah, everything was working. So that was pretty cool. So to wrap up, it's the exact same topology, but using 2 very different sets of resources. We have the GENI network, and they did some base configuration for me, but I set up the VMs and then got them connected and then ran the configuration. Locally, I built my own ESX deployment, my own small physical network, and then did the exact same configuration. A little more work on this side, and I needed some additional resources. Neither one of them is very costly, right? GENI is an NSF-sponsored thing, and it doesn't cost me anything to run that. The local ESX thing was a little bit more money, but it was with cast-off equipment, so I didn't actually spend a dime. The ESX box is an HP box running a 200 gig hard drive, I think, if I remember right, and then 6 or 8 gigabytes of RAM, and then I've got an old router and an old switch sitting there. But the nice thing about this is that because both of them worked, it's the exact same topology, I can use either one of them as the base for additional experimentation and research. Now, there's lots of stuff that goes into this, right? If you look at all the modifications, we were networking, we were VLANs, we had virtualization running, there were SSH keys and SSL keys and SDN. Anything breaks, we're troubleshooting it. But if you get through it and you understand what you did, well, hey, that's a pretty nice feather in your cap.
Well, there you have it, boys and girls. Hopefully you got something out of this topology build. Coming up, what we're going to work on are some different things you can do with SDN. So we'll be looking at some other structures. This one was just a simple layer 2, just to sort of get our feet wet. But we'll be seeing what else we can do. Things like GRE, maybe some layer 3 routing, and then some use cases. Until next time, may your packets always reach their destinations.